Good evening, everyone. Welcome to this community information webinar for the Victorian Renewable Energy Terminal. My name's Jenny Forrester and I'll be hosting tonight's presentation. And before we get underway, just a few housekeeping notes. So at any time during this webinar, you can type your questions into the chat. We'll have a dedicated short Q&A section after the project presentation, and we'll get through as many of your questions as we can. And I would like to note that in the Q&A where you type your question, all questions asked will be public for everyone to see. If you're having any technical issues, do first try refreshing your Teams window, or if you need to rejoin the session. And if those technical problems are persisting, there is a further option. You can email engage@portofhastings.com.au. That's engage@portofhastings.com.au, and a member of our team will be able to give you a hand. And just a final note to say that this session is being recorded and it will be uploaded to the project website. So before we get underway, I would like to acknowledge the Wurundjeri Woiwurrung people of the Eastern Kulin Nation as the traditional owners and custodians of the land where I'm presenting from, and I pay my respects to their elders past and present. I'd also like to extend this acknowledgement to the Bunurong people as the traditional owners and custodians of the land and waters where the Port of Hastings operates. I pay my respects to their elders past and present and extend those respects to any First Nations people joining us online tonight. So, our agenda for tonight. We'll begin with an introduction and project update from Peter Watt, the Project Director at the Port of Hastings Corporation. And Peter will share some specific features and elements of the design options being considered for the project and the work the project team has been doing to understand construction and operations for the terminal. And following this, Natasha Reichschneider, Approvals Manager for the project, is going to speak about environmental assessments underway and provide a bit more detail about some upcoming engagement. And then we can move on to your questions. So I will now hand over to Peter, who'll start this session off with a short animation about the project. Thanks, Peter.
Good. Thanks, Jenny, and welcome everyone. We really appreciate all the attendance tonight and the interest in the project. So my name's Peter Watt. I'm the Project Director for the Victorian Renewable Energy Terminal at the Port of Hastings. So just to begin the presentation, the Port of Hastings has been selected by the Victorian Government as the preferred location for the establishment of Victorian Renewable Energy Terminal. This marine terminal that we're proposing is critical to supporting the state's ambitious offshore wind generation targets and achieving net zero emissions by 2045. I will start the presentation by sharing a short animation which will outline how this project fits into the development of offshore wind.
The Victorian Government is establishing a thriving offshore wind industry, paving the way for our state to host the first offshore wind energy projects in Australia. Wind blows much more consistently out at sea, and Victoria has some of the best offshore wind resources in the world to support a clean energy future. The Port of Hastings has been selected as the location for the Victorian Renewable Energy Terminal and, subject to the necessary approvals, will become the dedicated assembly port to import, pre-assemble and transport offshore wind components to wind farms in Bass Strait off the Gippsland coast of Victoria. Offshore wind production refers to energy that is generated when winds at sea turn large turbines, producing clean, reliable and renewable electricity. The electricity produced travels through undersea cables from the turbines to a land-based substation, where it is connected into the existing transmission grid infrastructure. To construct an offshore wind farm, supply ships first deliver the wind turbine components to the Victorian Renewable Energy Terminal at the Port of Hastings. These components will be stored at the terminal and include the foundations, towers, blades and power generation units. Some wind turbine components, such as the tower segments, will then be pre-assembled at the terminal before being loaded onto specialised installation vessels for transport to offshore wind farms. The installation vessels will transport and install the wind turbines at their locations in Bass Strait off the Gippsland coast. Each installation vessel can carry and install multiple wind turbines before returning to the terminal for reloading. Victoria's offshore wind farms will produce 2 gigawatts of power by 2032, 4 gigawatts by 2035 and 9 gigawatts by 2040. 2 gigawatts of power is enough to power 1.5 million homes. Specialised port infrastructure is required to support offshore wind construction due to the size and weight of offshore wind components. The Port of Hastings has been selected as the most suitable location for the Victorian Renewable Energy Terminal, with the benefit of having large areas of available land next to deep water channels, proximity to proposed offshore wind farms and adequate channel capacity to manage specialist vessel movements. The Port of Hastings Corporation will develop the terminal in consultation with traditional owners, communities and industry. Together, we can support clean, renewable wind energy for our future. For more information about the Victorian Renewable Energy Terminal project, sign up to receive updates via our website.
Good. So just a bit about Port of Hastings. Some in the local community may have good knowledge about the Port of Hastings and others probably don't. But the Port of Hastings is located in Western Port and is approximately 70 kilometres southeast of Melbourne. It's one of the 4 major working commercial trading ports operating in Victoria, and it's been operating for close on to 60 years. It's got a natural deep water channel, 3,500 hectares of land that has been zoned for port-related use. And the typical trades that we do through the port at the moment includes import and export of crude oil, liquid petroleum gas, steel exports, and imports of petrol and diesel. We currently have about 100 to 150 commercial vessels that visit the port each year. And that's whereas back in the 1980s, when the BP refinery was in full swing, there was around 700 commercial vessel visits per annum. So the Port of Hastings is set to play a key role in the Victoria's renewable energy transition through the establishment of the Victorian Renewable Energy Terminal. So in the animation, you saw a still of this, or this is a still from the animation. So it shows the location of the Victorian Renewable Energy Terminal in respect to where the offshore wind zones are planned for Victoria. So compared to the other commercial ports that are operating in Victoria, we have good proximity. So we're the closest commercial port. And offshore wind will be a key component in Victoria's renewable energy strategy and transition. So the Victorian Government is committed to delivering 2 gigawatts of offshore wind energy by 2032, 4 gigawatts by 2035, and 9 gigawatts by 2040. And why are we proposing this new marine terminal at the Port of Hastings? This is about energy security and the development of new renewable energy sources. We have a number of coal-powered fire stations that are slated for retirement, and the gap needs to be filled with renewable energy sources. So this will be a key new renewable energy source. So then if we zoom down into Western Port, so Western Port's characterised by, to the south, we have Phillip Island. In the middle of Western Port, we have French Island. And on the western side of Western Port, we have the Port of Hastings. And the Port of Hastings has 4 commercial wharf facilities and the Victorian Renewable Energy Terminal, which is a small dot within that purple area, is located towards the northern part of the Port Corporation waters. Well, it's a bit hard to see. The purple designates the Ramsar wetland, and then you can see the reclamation area and the dredging envelope that we're proposing for the VRET terminal. A Ramsar area, that identifies wetlands of international importance, and especially those providing waterfowl habitat. And so in building or in the designing and hopefully building of the terminal, we need to balance the technical imperatives with protecting the environmental values in our surrounding area. So Port of Hastings Corporation recognise the importance of the Ramsar wetlands, and working with our engineering and approvals and environmental team to propose an appropriate design. Now, in terms of offshore wind, there are three key pieces of the puzzle. So the first one is generation. So there will be private offshore wind developers, which will bid for power supply contracts through the Victorian Government, and those that are awarded those contracts will then go and construct the offshore wind farms. There's the transmission component. So VicGrid, which is part of the Victorian Government, will oversee the delivery of new transmission infrastructure to deliver the energy generated from offshore wind to homes and businesses throughout Victoria. And the third key component is the ports. So the Port of Hastings Corporation will oversee the development of the Victorian Renewable Energy Terminal, which will support the construction and development of the offshore wind farms. It's also important to note that there is no existing port currently in Victoria that can facilitate offshore wind assembly, because of the specific requirements around the loading that you apply to these terminals and the areas of or terminal area that is required. So why does the Victorian Government prefer the Port of Hastings? So the Victorian Government has come and said the Port of Hastings is best placed to support construction of offshore wind projects, and it recommends the proposed development of the Old Tyabb Reclamation Area, which I'll show you in future slides for this purpose. So the key reasons that the Victorian Government, who has gone and assessed a number of potential port locations, has determined this to be the preferred location is because we have a naturally deep and wide existing shipping channel. Because it is deep, there's minimal dredging required, capital dredging when we go and construct the project, and also ongoing maintenance dredging, which therefore minimises the environmental impact. We also have the best proximity to the offshore wind farms, which reduces sailing times and thus costs to consumers of the power, and also speeds up the delivery times for the offshore wind development. We also have flexibility. So there's a lot of available port land which has been zoned for port-related uses, which adjoins Western Port in Port of Hastings. So now we zoom into the proposed project site. So you can see the red dotted line, which indicates the footprint of the proposed project. This is located at the Old Tyabb Reclamation Area. So that was an area that was reclaimed back in the 1960s from material that was dredged out of Western Port. And to the south of that, we have the Long Island Point liquids berth and the Esso fractionation plant. And then to the north, we have the BlueScope Steel wharves, and out of picture is the BlueScope Steel manufacturing plant. The other thing I'll just mention is that the sort of area that we're looking for the project in terms of the reclamation and where we do the dredging is about 0.1% of the total area of the Ramsar wetland within Western Port. So I think you can see that from the previous slide, which was quite difficult to see, but a very sort of small area compared to that Ramsar wetland. Good. So I mentioned the Old Tyabb Reclamation Area, and that's a blow-up of the site there. This is a site of about 25 hectares, and the key reasons why that was identified is because it's existing land zoned for port-related use in a highly industrialised area. It sits between the Esso fractionation plant and the BlueScope Steel manufacturing facilities. It's government owned. We've got good access to arterial and freeway road network, adjacent to a existing deep water channel. And there's no environmental or very few sort of environmental issues with the OTRA site because it's a lot of introduced sort of paddock grass and other non-Indigenous or native species. The OTRA site was the clear location because there are no other public land sites within the Port of Hastings that provides these benefits. Good. So that describes the process in which the Port of Hastings Corporation and the Victorian Government landed on this particular spot for the Victorian Renewable Energy Terminal. So what I'd like to do now is give a bit of a status update for the project. So an environmental effects statement, or an EES as we commonly term it, is required for the project, and this process is currently underway and is a state-run process. Extensive ecological assessments, technical studies and engineering work has been carried out and continues to be carried out to provide an in-depth understanding of the site and the surrounding environment. We're also undertaking a detailed review of design options. We've completed significant parcel of geotechnical studies to inform the engineering design and also the environmental aspects that need to be studied. And we're continuing to do a significant number of field investigations to understand the existing environment baseline conditions and to help inform our impact assessments, and continued engagement with key stakeholders and industries. Now, through this work thus far, we've made substantial reductions to the dredging and reclamation envelopes that were detailed in the 2023 EPBC referral, which is the federal government process. And we will talk about that in a bit more detail as I go through the presentation. Just to highlight the sort of engagement that we're having, these consultation sessions, and we had all virtual online sessions and community drop-in sessions, and ongoing briefing of the community and stakeholders is a very important part. And we seek to gain good feedback from the community and stakeholders, which will help inform the design. We've also got very close engagement with the Bunurong Land Council, and it's a very positive relationship that we've formed thus far. So talking a bit more detail about the project field investigations, we currently have over 20 environmental studies underway. We're gathering data around the site and the wider Ramsar area as we seek to enable a science-based impact assessment. I won't read out all of these studies, but as you can see, there's a lot of work going on and will continue to go on right throughout until the completion of the EES process. Thus far, no significant impact has been identified from all of those studies, but work needs to continue throughout the full EES process to complete that work. We've also been doing a lot of design options assessment. So been doing extensive technical studies to better understand the surrounding environment, including the engineering and design work. It's very important for the Port of Hastings Corporation to balance the technical imperatives required to build this significant, important piece of infrastructure, energy infrastructure, while protecting those important environmental values of Western Port. I mentioned on the previous slide, since the 2023 EPBC referral, we've managed to make substantial reductions to the previous dredging and reclamation envelopes. And this has been achieved by going through a thorough and detailed design options assessment process. I'll now take you through our methodology and the new design that we have arrived at. So this is an image or a drawing of what we put into the 2023 EPBC referral. For those that aren't familiar with EPBC, that's the federal government process. And what that had was there are three main components. The light blue one is the existing Old Tyabb Reclamation Area. The green area was potential dredging and reclamation area. And then the yellow area was the potential dredging area envelope. So the work that we've done since that referral, and if we now move to the next slide. So what this shows is that Old Tyabb Reclamation Area, that's a similar sort of area that we're adopting, but the reclamation and the dredging area, we've been able to significantly reduce the footprints. So we've taken on board comments from the federal government and really looked very closely at what was required to meet the government's requirements for the offshore wind and the targets, and managed to go and trim down the areas quite significantly. And we've been consulting with state and Commonwealth government and agencies and key industry stakeholders throughout this process. It's also very important to note that our updated design does not compromise on safety. This facility will have larger ships coming in, and the footprint needs to consider the turning circles and safe manoeuvrability for those vessels. So this is a artistic render of the proposed site once it's completed. So you can see the yellow dotted line, and that outlines the footprint. To the south of the site, we have a Long Island Point liquids berth, which is part of the Esso fractionation plant. And then to the north, we have the BlueScope Steel wharves. So both of those facilities are existing industry, and we have a number of vessels coming in each year to service imports and exports through each of those wharves. What the new facility will look like once constructed and in operations is you will see essentially it'll be a largish laydown area for offshore wind turbine components. So some of those key components are, we have jacket structures, which are they're the yellow truss type structures, which you hopefully can see that red cursor moving around. They're the foundations for the turbines. They will sit on the seabed and then protrude up above the water level. We then have the towers. These towers get erected at the berth. They come in three components, three sizes, and then get erected and pre-assembled on the site. And then we also have wind blades and nacelle units. So all those different components come to the site, get stored there, pre-assembly work is done, and then an offshore installation vessel will come and pick up a set of 5 sets of components to transit out into the Bass Strait for construction of the offshore wind turbines. So now I'm going to talk about construction and operations. So in terms of construction of the terminal, there's a number of different elements that need to be built to complete the facility. And so I'll start with that, and then we'll talk about a bit more detail about how some of the operations will work. One of the key components in the design of this facility is that we need to ensure that the marine terminal can hold the very large and heavy components. And you will see from some of the slides that we've got coming up, the componentry that is handled, components are very large, very long, very heavy. And so the marine terminal needs to support significant weights. So some of the key areas within the terminal is the orange area, which is the operational area. So that will comprise storage of the units, and there'll be some pre-assembly work going on in the units in that area. There's a retaining structure around the perimeter, which will be like a rock revetment, to retain the operational area. The blue area is the quay apron. So that'll be, the ships will berth up against the quay wall, and then these very large components will be loaded onto the quay apron. So it's a very heavy duty area. And then we have the berth pocket. The berth pocket is not a physical bit of infrastructure. It's a deepened area. It's a deeper depth of seabed where the ship's more up against. So in terms of some of the size of the components, in the left-hand image, we can see tower sections that are being unloaded from a vessel. So this photo is taken from another similar facility to what we're proposing. If you can look at the size of the people and the size of the tower section, you can get appreciation of just how tall these components are. So we expect these would be 10 or 11 metres in diameter. So they're almost as tall as maybe 2.5, 3 stories in height if you were to build a building. On the right-hand side, that shows transition pieces. And these are transition pieces which sit on top of foundations in very significant size, yet turbine components. The turbines are significantly bigger than what you would find onshore. So I mentioned the very high loads that we need to design this terminal for. On the left-hand side, typically, if we were designing a typical container terminal, such as what I've got up in the Port of Melbourne, at Swanson Dock, or for the VICT terminal, we'd probably be designing for a load capacity of about 5 tonnes spread over a 1 square metre area. But in the heaviest loaded areas for the terminal that we're proposing, we're looking at 30 tonnes per square metre. So there will be areas of the terminal that are 10 tonnes per square metre, some that will be 15, some that will be 20, and some that will be 30. But this is the very high load that gets applied to the terminal is one of the key reasons why no other commercial port facilities in Victoria can handle this type of trade in their present form, because they don't have the load capacity to do it. So some of the key construction activities, depending on, hopefully we'll get the successful environmental approval to proceed, and then we'll start mobilisation on the site. A key element will then be the landside work. So that's on the existing Old Tyabb Reclamation Area. We need to do some ground improvement. So that's helping to consolidate and strengthen the ground prior to putting on heavy duty pavements, and also putting drainage systems within the pavements. We'll be constructing permanent facilities. There will be some offices, warehouses and workshops. Then we need to do some dredging. So although Port of Hastings has a naturally deep water channel, in some areas we still need to dredge down a bit further to accommodate the type of vessels that will be coming to the terminal. So as I mentioned before, we've managed through a lot of work to reduce the amount of dredging compared to what had originally been proposed, but we do need to do dredging. We'll then be doing reclamation. So reclamation is building up or creating land adjacent to the Old Tyabb Reclamation Area site, and that will be done through bringing in of fill, engineered fill, so sand and gravels, and then we'll be doing some piling works. So piling large steel tubes that we drive into the ground to then allow us to go and create the quay wall, which is the main structure that holds back all the sand, which is probably best shown in the next slide. Yes, in the next slide. So with the quay wall, so this is the ships berth up against the quay wall, and they sit there while they're being unloaded or loaded. We're looking at 2 engineering options. I won't get into the detail of it, but one's called a twin wall cofferdam and another a caisson wall. We're That has to be a fairly large structure because it's got to retain a significant height of soil to give sufficient depth for the commercial vessels to berth up against. We're looking at both two options in detail at the moment and doing the environmental impacts and trying to determine differentiators from an environmental perspective and other perspectives as well. So we have not landed on one particular solution, but working through that. Good. So this slide is meant to represent or to convey the sort of visual impact that will be a part of this terminal. So you can see there's the turbine tower height of 200 metres, which is sort of in the centre of the slide. So those towers will be erected at the terminal. They're not a permanent feature. They come in 3 pieces. They progressively get bolted together and then they get put onto a ship and taken away. And then the next tower section gets erected. Also at the terminal will be the turbine jacket foundation structures, which could be up to sort of 90, 100 metres in height. And you saw those in the render. Now, these are large structures. The structures we're showing on this slide are actually not ones that won't be at that height when the terminal first goes into operation, but they're more of a turbine that might come in 10 or 20 years after the first operation. But we wanted to show, what would be the worst in the future rather than at startup. And we also have the Rialto Tower there just to give you a bit of perspective. And to the left of the Rialto Tower is the assembly crane, which will have a single assembly crane, we expect, which will be used to go and erect the tower sections. We also need to consider through the EES process, well, I've spoke about the visual considerations of the cranes and the towers, but also lighting when we're doing the operations for the terminals and even aviation impacts due to the height of the towers. Good. So this is a graphic, sorry, not a graphic, it's a photograph taken of a similar type of terminal to what we're proposing, and it's overseas. And just to reiterate, there's currently no offshore wind industry in Australia at the moment, but there is a lot overseas and it's expanding, and there's been more and more development, particularly in Europe and Asia and the Americas. So what we can see at this terminal is an offshore installation vessel, which has got a series of blades. You can see the turbine blades if we just put the cursor on that. Yeah, it might be a bit hard to see the cursor, but anyway, that is the offshore installation vessel, which has come to pick up a set of blades, a set of tower sections, and also nacelle units. Nacelle units are the bit that sits on the tower, converts the kinetic energy from the turning of the blades into electrical energy. And then on the port facility, you can see the different components which are placed in different areas around the yard. And then going to a couple of other photographs. So on the left, we can see tower sections. Then top right, that has the nacelle unit and the blades. And the bottom right is, it seems to be something to do with the nacelle unit. So the nacelle unit. And this is transition piece. Transition pieces sit on top of the tower. On top of the foundations. And then on the right, we have jacket structures. So that's the amount of the jacket structure which protrudes from the water level out at the offshore wind farm. So then all of those components, after they get taken out to the offshore wind field, make up the turbines units. And so in the right, that's a visual of a completed turbine unit. And on the left-hand picture, That's offshore installation vessels doing the installation for the turbines. Good. So I would now like to pass over to Natasha Reifschneider, who will talk through the environmental assessment process.
Thank you, Peter, and good evening, everyone. As Peter mentioned, my name's Natasha Reifschneider and I'm the Approvals Manager for Port of Hastings Corporation. In the next few slides, I'll give you an overview of the environmental assessment process Port of Hastings has started for the terminal project, and I'm going to explain the work we're doing to prepare the environmental effects statement. In 2023, the Port of Hastings referred the terminal project to the State Planning Minister, and as a result, an environmental assessment was determined to be required under the Environmental Effects Act. This assessment process doesn't actually approve the project, but it helps decision makers understand the environmental impacts, which is crucial for their understanding when they're deciding whether to approve the project. The Environmental Effects Act in Victoria provides for environmental impact assessment for projects capable of having a significant effect on the environment. There are 5 main phases for this process, which the Port of Hastings is currently working through. The first phase, which is in the green box there, we have completed. We've already made our referral under the state process, and we know that we need to prepare an environmental effects statement, or EES, for the project. The second phase is a scoping phase, which we're in right now. This phase is where the matters to be investigated and documented in the EES are set out in the scoping requirements that are issued by the Minister. The third phase is the preparation of the environmental effects statement, which essentially is a large impact assessment report, which I'll explain a bit more in the next slide. The fourth phase is public exhibition, which occurs when the Minister for Planning is satisfied that the EES is appropriate for exhibition. At this time, that's when the public can make submissions on the project. The final phase of the process is the Minister's assessment of the environmental effects. And during this phase, the Minister appoints an inquiry to evaluate the effects of the project after reviewing the studies and the public submissions. The Minister then prepares an assessment considering all that relevant information and the inquiry report. Further information on the Victorian Environmental Effects Statement process can be found on the Department of Transport and Planning website, and we've included a link there on the slide for you. As I mentioned in the previous slide, the key document prepared through the environmental assessment process is an environmental effects statement. The Port of Hastings has commenced work on the EES for the terminal project. The environmental effects statement includes a number of key elements. There's the project description that sets out what the project is, and Peter's explained that tonight. It outlines the public and stakeholder consultation that's been undertaken, what we've heard, and how we've responded to what we've heard about the project. It also includes a description of the environment that may be affected, so what the existing conditions are, what our surveys have told us, so we can understand and put down that basis of the environmental values of the area. It also includes predictions of environmental impacts of the project and alternative designs and issues that we've considered. We also look at measures to avoid and minimise and manage environmental effects. And the EES also includes a program for monitoring and managing those environmental effects during the project development. A technical reference group and an independent expert group has been appointed by the Department of Transport and Planning for this project. The technical reference group includes members of government, agencies, local government and statutory authorities, whilst the independent expert group includes independent experts engaged by the Department of Transport and Planning to provide technical advice. The EES isn't expected to resolve all the matters with the project, but it's designed to provide information on the environmental issues that decision makers need to understand and consider. Right now, there are 21 technical studies underway for the terminal project to help inform the environmental assessment. And you can see all those studies listed on the screen there. These studies cover a really wide range of topic areas like marine ecology, air quality, noise and light. And some of them obviously are land-based as well. The goals of the studies is to look in detail at the existing conditions on the land and waters and assess how the project might impact those conditions, and also come up with recommendations and ways that we can manage or mitigate any of these potential impacts. Along with the state assessment, we also need approval from the Commonwealth Government under the Environment Protection and Biodiversity Conservation Act for the project to proceed. As some of you may well know, last year the Port of Hastings Corporation submitted a referral to the Commonwealth Government to determine whether the project needed formal assessment and approvals at the federal level. In December 2023, the Commonwealth Government determined that the project as referred was not to be given a controlled action. For context, under any act, anything that could have a significant anything that could have a significant impact on national matters of nationally significant environmental matters is considered a controlled action that needs approval from the Federal Environment Minister. Port of Hastings has listened to the outcome that we had last year, and we have been investigating these statements of reasons that were provided to us and doing the work since then to understand the environment, do some more technical assessments and work up a design that responds to those matters and those reasons raised by the Commonwealth. We've also been having conversations with the Commonwealth Government because we need to ensure that we're really confident that the issues have been addressed that were raised in that 2023 decision. A new referral will be made to the Commonwealth when Port of Hastings is confident that the environmental studies and the science confirms that the project is appropriate and it's not likely to have a significant impact on the Ramsar site or any other Commonwealth matters. And we're still doing this work to get to this conclusion. In terms of where we are right now with the project, we have commenced a program of engagement activities to update stakeholders in the community about the project and the changes to the design that we've made. We held a drop-in session earlier this week at the Hastings Town Hall on Tuesday night, and we'll be holding another one this Saturday. So if you're available on Saturday, get down and come and talk to our team. We are committed to developing the project with the traditional owners, local communities and industry. And to facilitate this dialogue, we're also looking at establishing a community reference group to provide a regular forum for the community to discuss the project. We also anticipate that the Department of Transport and Planning will release shortly the draft scoping requirements, which sets out the matters to be investigated through the EES. The community will be invited to make comment on the scoping requirements when it's released, and a copy of those scoping requirements will be made available through the Engage Victoria website. To wrap up, as we keep making progress on the project, we'll be sharing updates with the community through our project newsletter and on our website. We encourage you to sign up to our mailing list on our website to receive a copy of the project newsletter. Thank you for listening, and I'll now pass back to Jenny.
Thanks very much, Natasha, and to Peter as well. A lot of information to get through. I hope you're still with us. I can see there are a few questions coming through. So we've just had a presentation, quite a comprehensive one, on the proposed Victorian Renewable Energy Terminal project, both the project's purpose, key elements, but also the process for assessing the project's potential effects. And some of the questions we have coming up relate to both the project's rationale and concerns about the project's potential impacts. Peter, I will pass to you with a question about the project's rationale and why this project is being presented again and this information being presented, given, as Natasha outlined, the Commonwealth Minister had made a determination that the project not be given a controlled action under the EPBC Act. So why, Peter, is the project being proposed? And then, Natasha, I'm going to ask you to speak about some specific effects there are some concerns about. Thanks, Peter.
Good. Thanks, Jenny. So Port of Hastings, we understand this is the first time the broader community has seen details on the project since the EPBC referral decision. The Victorian Government has confirmed the Port of Hastings as the preferred location for the Victorian Renewable Energy Terminal. It has determined that an environmental effects statement is required for the project, and works on the EES are in full swing. We're now commencing a program of engagement activities to update stakeholders in the community about the terminal and the changes to the project design. So we're committed to developing the terminal project in consultation with traditional owners, the local communities and industry, and through comprehensive assessments that recognise the important environmental heritage and community values of Western Port.
And Natasha, Sue's question, which Peter has responded to part of, definitely raises some concerns about key elements of the site and the broader Western Port. So wildlife, bird migration, the mangroves, which are very prominent in Western Port. What is being done to protect those values and features?
Thanks, Jenny. We're doing a lot of work to understand not just our site, but the broader Ramsar site. We're doing, and we have been doing for some time now, probably over a year, a number of ecological studies. We're doing underwater marine studies, bird surveys, lighting surveys, and a range of other surveys I think I had up earlier, just to really understand the values of the Ramsar environment and understand how our project will impact on those values. And through understanding that, we can then look at the design of our project and look at ways we can try and avoid and mitigate any impacts that we may be having through the way that the project evolves.
And there's, of course, excellent local knowledge about Western Port, about particular values in the Ramsar site. And I think the concern that I'm seeing coming up through some of the questions is it is a well-known, prominent, internationally recognised site. So what sort of confidence can you provide about things like the impacts of dredging, about the process for understanding those potential impacts? Natasha, could you speak a little bit more specifically on the dredging and that process for understanding those potential impacts?
Sure, yes, I can, Jenny. So specifically on the dredging, what we do there is we understand we do the studies, as I said earlier, about understanding existing conditions in Western Port. And then we look at the different options, dredging options that need to be investigated for the project. And we do some modelling and we look at the ways that the dredging may impact the environment. And then from understanding the potential impacts, we can look at how we can modify the design or the dredging methodology or equipment used to try and minimise those impacts. We also can look at ways in which we can, different ways we can manage the dredging spoil material to ensure that the impacts on the environment are minimised. And And as I explained earlier, we are in an environmental effects statement process, which is the most rigorous process in the state to assess environmental impacts. The scoping requirements are quite prescriptive in terms of what we need to consider. And obviously, we also have requirements for dredging that we need to take into consideration with design that are set out by EPA and DECA and other state authorities.
Thanks, Natasha. And there may be some more questions, I'm sure, that come up about assessing the project's potential effects. But I'll move now, Peter, to some questions about the actual size, scope, elements of the project. So the proposed size of the reclamation area and the size of the dredging area. Can you just recap some of that information? So that's the OTRA, the size of the OTRA, and then the size of the dredging area. Thank you.
Yeah, for sure. Thanks, Jenny. So the Old Tyabb Reclamation Area, OTRA, that's an area of about 25 hectares. So that's existing. And so we're looking at developing over about 22 hectares of that area. We're looking at a total terminal project site of around 40 hectares. So that requires about an additional 12 hectares of reclamation. And then in terms of the dredging, I showed an illustrative look about the dredging footprint that we've got. So you can see that the amount of dredging we've been able to pull back quite significantly from the earlier 2023 EPBC referral.
Thanks, Peter, and I'll stay with you if that's okay, because there are a couple more questions coming up about things like the length of the quay and then the site's operations. So how many ships would be expected each year? How many ships can berth at the new wharf? So quay length, expected ships per year, ships at the wharf. Could you just cover some of those facts and figures?
Absolutely. So so we're looking at around a 600-metre length of quay, so of berthing length, but we're still doing a lot of engineering design work and optimisation and looking at the supply chain logistics and talking with offshore wind proponents. So it's around that sort of order, but that's a work in progress. In terms of the number of ships, I might just elaborate on the type of ships. So compared to the size of ships that we currently get into Western Port for the Esso, and also we have a facility down at Crib Point. So you're getting those crude oil tankers and petrol and diesel tankers. They're around 260 metres in length, the larger size of them. What we're looking at for the offshore wind for the VRET terminal is around between about 150 up to about 225 metres in length. So the ships that come in won't be as long as the current type of vessels that come to the port. In terms of the number will be very dependent. So the number of vessels coming to this terminal will be very dependent on the size of the turbine units that the offshore wind proponents actually go and install. So some offshore wind proponents talk about could be a 1 gigawatt facility, and they could use turbines which can each generate at max 15 gigawatts, or it could be 18 gigawatts or 20 gigawatts. So the higher capacity of the turbines means the less number of turbines for that development, and that impacts on the number of ships. So it's a bit hard to give a figure at this stage until we get a bit more clarity from the offshore wind proponents.
All right, thank you. Thanks, Peter. I'll give you a break for a moment. Natasha, just following on from the questions about operations, about how many vessels, their size, just understanding how the EES and the environmental assessments would consider risks of fuel spills, both from vessels and in relation to any aspect of the site's operations and and the materials and equipment that the vessels will carry. How is the EES going to consider things like risks of fuel spills?
Thanks, Jenny. So part of the environmental assessment, the environmental impact assessment is a risk-based assessment. So we need to look at the potential risks that the construction and operation of the terminal may introduce to the environment. So things like fuel spills, absolutely. We need to consider the likelihood of a fuel spill event or any sort of impact event on the environment, and how we would mitigate a risk of that occurring, and if it was to happen, how we would manage that impact. It's all required as part of the impact assessment, and absolutely something that we are considering.
Thanks, Natasha. So back to you, Peter, a question about, another technical question in relation to fill that might be required for the construction of the holding and the wharf sites. So what sort of volume and where would that fill come from? Can you speak on that?
Yes. So we need to bring in engineered fill or good sand or gravel onto the site to go and create the new reclamation area. And so that will come from, we're still doing an assessment of different quarries, but we would like the quarries closer to the terminal site to be used. But that's, a bit of a work in progress at the moment. And we will also be using the dredge material that we take from the seabed. We will be using that to help with the reclamation of the terminal. So because the silts that will come from the seabed don't have too much engineering strength, we'll actually be doing a bit of improvement to that by mixing some cement into it. So we are looking at a beneficial reuse of all that dredge material combined with new fill material that we'll bring from local quarries.
Thanks very much, Peter. I'll stay with you for a moment, if that's all right. A couple of questions about the potential land transport effects of the project and how they'll be catered for. So questions about good access to arterial and freeway road network, as your presentation covered, and any work to transport components, the effects of the project on surrounding areas. I think there's some questioning coming up about existing traffic challenges around the Port of Hastings, around the BlueScope and United Energy sites. So perhaps, Peter, you could speak about transport from a design planning point of view and the project scope, and maybe then Natasha, if you would speak on the impact assessments. Peter?
Good. So there are two distinct phases. When we do the construction of the terminal, yes, it's beneficial that we've got that good access to that arterial network, and we will be bringing fill in trucks onto the site. There'll be some components that are brought in by road and other components that are brought in by vessel. So, for example, some of the large amounts of steel piling could come in by vessel, so that would not have an impact on the local roads. But definitely fill and gravel materials during the construction period, yes, there will be an increased amount of traffic through the Hastings area. Then once we get into the operational phase, now the components that we're bringing in are so big that they can't be manufactured, say, for example, up in Dandenong and brought down the road by either truck or train. They're just too big to be supported by the road network, both physically in terms of size and also the weights that they would apply to the road. So the terminal the components will be delivered by ship and they'll be taken out by ship. There'll be a very small amount of peripheral materials that may come in by road, but again, a very small percentage. So I guess just to summarise, during construction, yes, there will be an impact, but after construction is completed, there'll be very little difference to the current networks.
And Natasha, if you could also speak about, I believe Peter's touched on it somewhat, but understanding current transport challenges in the area and the project's potential effects on the transport network. Thank you.
Sure, Jenny. So we undertake a traffic impact assessment as part of the project. And what that means is our specialists, our traffic engineers, they organise a program of traffic counts and understanding the existing traffic movements on the surrounding road networks and arterial roads, and assess what's happening now in terms of truck volumes, car volumes. And they also do an assessment on the road capacity to carry additional trucks and light vehicles in and out of the site. So there's really a lot of work put into understanding what's happening now. And then what we do from that point is we overlay what's proposed as part of the project. So looking at how the current road network will respond to having additional trucks and traffic movements brought by the project, and to really understand whether there needs to be any upgrades to roads or road pavements, impacts on surrounding networks and arterial road networks. Thanks, Jenny.
Natasha, I'm going to stay with you for a moment, and then we'll just address one or two more questions before we finish up for this evening. So we've talked about a whole range of different potential effects, and you've spoken about the EES process and the many study areas. Peter touched on the height of the towers, and I believe there are some questions and concerns about that. So height, visual impacts, even light. Again, could you speak about the assessment process and how those issues are going to be looked at?
Sure, Jenny. Yes, I can. As Peter presented earlier, the towers on site will be very large, up to 200 metres in height. There's no turning away from that. That's what these towers are. They're for offshore wind. They're very large. So absolutely, we have to consider the landscape impacts from these towers, not only on the OTRA site, but as they move through the channel out of Western Port Bay. So how we do that is, again, we look at the existing landscape, and we look at existing public access points and view lines, and this is undertaken by a landscape specialist. And then as part of that assessment, the specialist looks at the impacts from those different viewpoints onto the site, and how the landscape may change from hosting these towers as they're assembled on site and transported out to the head. So all of those potential impacts and impacts from the view lines will be documented in our EES.
And so the project or the assessment's going to look at not just impacts in the construction location, but impacts quite a lot wider, as you've spoken about. Can you tell me, is the project going to be talking with just Western Port communities, or are there engagement activities further afield, like Phillip Island, French Island? Can you talk about that?
Yes, I can. So we definitely are engaging with residents on French Island and the wider Western Port community. As I mentioned earlier, we have a drop-in session on Saturday that is open to the general public, and we also have upcoming engagement sessions as we progress through the project and the environmental effects assessment process. So we're really early in engagement, Jenny. This is our second session, so we're just kicking things off. And absolutely, if we hear from communities that specifically want to talk to us, we're very open to engaging as much as is required for the community to understand the project.
Thanks, Natasha. Peter, just one or two more questions for you. I think there's so much interest in offshore wind, which of course is not in operation in Australia at the moment. A question demonstrating a fair bit of knowledge. There are different types of offshore wind construction: fixed bottom, floating turbines. So this question is about whether the project has taken into account how it would manage or cater for floating offshore wind. Could you talk about those differences and what's been considered?
Yes, Jenny, I can. So fixed foundation offshore wind turbines are what we're expecting for the feasibility zones that have been declared off the coast of Victoria. Those, you can use fixed foundations, which are a more cost-effective type of turbine when the water depths don't get too excessive. So I'm not quite sure of the exact figures, but perhaps up to water depths of 60 or 70 metres, then you can use those fixed foundations, and typically it's either a large big steel cylinder pile driven into the ground or a jacket structure as the foundation piece that we showed in one of the renders. Now, Victoria's quite blessed in terms of it's got fairly shallow waters, and I still talk about 50, 60 metres, may not sound like that shallow, but when you start going out significant distance off the coastline, to have 50, 60 metres of water depth is quite shallow, and it's quite different to other states where you don't go too far off the coastline and you get waters, the depth drops very deep and you get water depths sort of exceeding that 90, 100 metres. And in those instances, then it's just not physically possible with today's technology to use a fixed foundation. So then what you have to do is use a floating foundation. So it's like a big sort of pontoon unit, which is tethered down to the seabed. So look, Victoria, so this terminal in the first instance has been configured to support the fixed foundation offshore wind turbines, and we expect that will deliver, we wouldn't need floating turbines for many, many, many years because we've got significant areas of shallow water.
All right. Well, Peter, I'm going to have one further question for you, but Natasha, just thinking about the project's next steps, it sounds like you're saying that there's a fair bit of work still to go, that a lot of work is being put into the project's development and assessment, and there's quite a bit to go. Would you be able to speak about key steps and timeframes in the process, including anything about the target timing for the facility to be operating? So just key next steps and then the project's operation.
Okay, so at the moment, as I explained earlier, we are still gathering a lot of information on the project. We're still undertaking the technical studies that we need to really understand the environment to have the confidence that this project is acceptable in the Ramsar site. So Jenny, answer your question, that's where we are now, and that is our first milestone. When we get to that point, when we have confidence that the project is acceptable, then that's when we start progressing through that environmental assessment process. And when we're confident, we will make a referral to the Commonwealth about this project. But there is still a lot of work to be done, and we're not at that point at the moment. Your question about when the terminal will be operational, I might ask Peter to answer that one, Peter, if that's okay.
Yeah, that's fine. So look, as Natasha said, we're doing a lot of work. We need to better understand, or we need to be in a position where we can confidently be in a position to go back to the federal government. And there's a lot of discussions going on with the federal and state governments in that regard. We're really not in a position to talk in any detail about delivery timelines, but I will say that Victorian Government's committed to the 2 gigawatts by 2032 and 5 gigawatts by 2035 and 9 gigawatts by 2040.
Thanks very much, Peter, and also to Natasha. We are going to bring things to a close. We've had a good period of questions, and I'm sure that you've got many more. Tonight's presentation is going to be made available on the project website, renewableenergyterminal.com.au. And any questions that we've missed from tonight, all the questions and responses will be packaged up and available on the project website. That is a good place to go as the project's developed and as you're seeking more information. But I trust that that's helped to provide a little bit more information about the project and the steps that are currently underway. So thanks so much for your time tonight. Hope you have a good evening. Thank you.